Hey, this is OXDF. We're doing Advent of Code 2024, day 17, and Chronospatial computer. So we have a 3-bit computer. That's to say we have numbers 0 through 7, and we are going to get a series of instructions and operands. And so each pair, so it's going to look, let's see, I'll come down here to the bottom. We'll have 3 registers that get initialized to values, and these don't have any kind of size limit. They're just numbers. And then I've got my program, which will be a series of numbers, and these will all be basically 0 to 7. And there's 2 types of things that can show up here. There's instructions and there's operands. The operands can either be literal or combo, depending on the instructions. The instruction will define that. And if it's a literal operand, it just means take the value. So the value 0 through 7. If it's a combo operand, 0 through 3 will be those values, but 4 through 5 and 6 will be the registers A, B, and C, and then 7 should never appear. So the specific instructions we can have will be opcode 0 does division. The numerator is the A register. The denominator is 2 to the combo operand. So I can divide by, I can divide by numbers 0 through 3, or I can divide by whatever values are in A and B and C. But interestingly, I'm dividing by 2 to the, which really just means I'm doing a bit shift to the left, or to the right, excuse me. Opcode 1 is a bitwise XOR. We take the literal operand and XOR it with B and store it in B. Opcode 3 is a combo operand and mod 8, storing the value in B. So take whatever in the operand, modulo 8, store it in B. Jump non-zero, opcode 3, does nothing if A is 0, but otherwise it jumps to the instruction pointer of its literal operand. This is interesting because it basically means we can only jump to the first. So I'm not expecting a very long program here. Normally these jumps, I would expect it to be like relative to the current one. But in this case, like we're literally just going to go to 0 through 7. So we basically have to go back to the start somewhere. Instruction 4 is a bitwise XOR of B and C, and then store the result in B. 5 outputs a value, and if a program outputs multiple values, they're separated by commas. Opcode 6, and it outputs the combo operand, so it can be any register, or I guess you could output a static value if you wanted. Opcode 6 works is a divide instruction, except for we store it in B. We read A divided by the is it combo operand? Combo operand mod. Oh wait, no. Combo operand mod 2, or 2 to the combo operand. We take B, we take A, we store it in B. And CDV works exactly the same, except for we're gonna store it in C. All right, so we're gonna take this program, we're gonna run it, and we're gonna determine the output here. So that was a longer introduction, but let's go ahead and jump in here. I will run GenDay, and this is day 17. We should grab our example. It's always a little hard to predict what they're going to do as far as part 2, a twist. I mean, part 1 should probably be pretty straightforward. We'll check our input. It's not that many instructions, kind of as I predicted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The jump instruction was, I guess we don't have to manually analyze this, but where was the jump instruction? It was 3. Yeah, 3. So these are pairs: 1, 2, 7, 5, 4, 5, 1, 3, 5, 5, 0, 3. So the only jump is right here. So we're going to run the program and then jump back to 0 repeatedly as long as A is greater than 0. Now we're spoiling it, but cool. Let's go ahead and program this computer up. What do we want to read in here? I guess I can, let's see, pull the example input to the side. Almost certainly under my head, but you all don't need to, you know what it looks like. We're going to read in, let's see, what's the easiest? I might just, honestly, we will do, let's feels kind of like cheating, but RE, data, f.read, and then we can do A, B, C, and then I star program equals re.findAll, and then we will look for \d plus. So we're just going to do that, and that's all we need, like that. So this will find all of the strings of numbers. So it'll find 729, 0, 0, 1, or 0, 1, 5, 4, etc. I want to those will be strings, so I want to map int onto that, and then I can turn that into a list so I can process it. And then the result is going to be a list of numbers. The first one will be A, the second will be C, the second B, the second will be third will be C, and the rest will be a list called program. So if we A, B, C, program, let's see what that looks like. Python day 17 example.txt. You can see we get 729, 0, 0, and then a list of the remaining numbers. So that's exactly what we want. I'm torn. Part of me wants to like make a class for this computer, and we might come back to that. But for now, I'm just going to start by, we're just going to do it regularly. I'm going to pull up this, move it to my other monitor so I can just see the instructions. So we will say instruction pointer equals 0. We initialize our instruction pointer to 0. We already have our registers initialized, so now we just need to say while I guess, do we say while true, or do we exit if IP, I guess, well, IP is less than the LAN program. Now we need to get opcode equals program IP, operand equals program IP plus 1. We're also going to need a function to define our combo. And this will take a val, which is an int, and it will return an int. And we are just going to do if val is less than, so I should look this up, 0 through 3. So is less than or equal to 3. Val. Now, if it's if val equals 4, I can make this a little cleaner. Return a. This is, well, maybe we should. Whatever. Okay. Well, too much. Let's see. What if we do reg map equals 4a? I don't know if that's gonna work, but that's gonna be at the time I set it. Oh yeah, that's fine. 4a, 5b, 6c, c, and then we can do turn reg map val. And if we get 7, that's going to throw an error. I guess we can assert val not equal 7, invalid combo value. All right. So now we have that. So now we can say operand equals that. So we want to say, I guess we'll just do, is this a case for switch? Match on opcode. Case of 0, this is going to be ADV. So we are going to say A is equal to, and this is okay. So we're going to take the numerator is the A register, and the denominator is 2 raised to the combo. So that really just means we're going to shift, we're going to bit shift by combo of A, right? Combo, oh no, combo of operand. Boom. Okay, case 1. I'm going to do it down here at the bottom. We will do IP plus equals 2 to make sure we move on. And we'll have to remember that the one jump instruction doesn't handle that, so we'll have to handle that differently. All right. Opcode 1 is the BST instruction. I don't find these super useful. I don't look up, oh, BST, I know what that means, but this is the combo operand mod 8 and is set to the B. So B equals combo operand mod 8. Case 2, and this is the BST. Oh wait, did I just do the wrong one? That is correct, that goes here. This one is BXL. I guess that's B, register B XOR with the literal. Oh, register B XOR with literal. Okay, so B is the calculate the value of the combo okay, so this will be B XOR combo operand. All right, this is just lots of typing here, but let's see, what is 3? 3 is the jump non-zero. Okay, so this will be JNZ. If A is not equal to 0, then we will IP equals, and what are we going to literal? So equals operand. Continue. So that gets us, basically when we get here, we will hit here and we'll go right up to the top of the loop again without going to the bottom and hitting our reset. Otherwise, if A is 0, we'll just continue. Case 4, and this is BXC. So let's see if I'm learning it. This will be B XORed with C and stored in B. B equals BXC. Case 5, we'll call this one, this is out. We are going to need an output. We could output this here, but that makes we're going to have to separate them with commas, and that feels kind of annoying. So we're just going to say output equals that. And we'll say output dot append. And this is a combo of operand. Case 6, and that is the BDV. And this is going to be the exact same as this one, except for we store it in B. In fact, if I remember correctly, the next one is CDV. The next 7 is CDV. And we're going to just do C divide like that. And I think that is all we need. Shrink that down. Part 1 is going to be comma dot join output. Let's give it a run. I think I didn't need that. Well, okay, let's try. I'm rushing here. Okay, so we're gonna take map string on output, and that's gonna give me a generator of strings, and then I want to join them. Oh, typing. Dot join on that. That should work, right? Yeah. There's our example. What was the example output? Oh, output is always mod 8. I need to do that. Output dot append combo operand mod 8. 4 6 3 5 6 3, and that matches what I've got here. So we can do this and grab you, and we got it. Not super exciting, mostly just typing, not hard to implement. The real challenge will come in part 2 probably. So let's go to give it a read. All right, so for part 2, I am trying to find the lowest value of A that so they give me ABC, but I'm going to throw out the A, and I'm trying to find the lowest value of A that produces the program as the output. So the program runs and outputs itself. So to do this, we're going to take a little look. We're going to look at our input because it's going to be very specific to our input. Let's make a text. Let's grab this right here, put it here, and I'm going to split this to the right so we can, hopefully I'm not too over my face, but let's see. So we need the instructions here. So let's look at what this actually does. So 2 4 is going to be combo operand mod 8 equals B, and that is going to be B equals A mod 8. 1 2 is our next one, so that's going to be BXL, so B combo should that be a combo? I'm surprised BXL is a combo operand. Now we solved for part 1, so I guess that must be right, but that should be a literal operand. I think we just never mess with it. So maybe it's always low enough that it doesn't matter. So this should actually be, let's fix that in our thing here. So b of operand, that's a b of b equals b x XOR 2. All right, the next one is 7, 5. That is C is going to be equal to A shifted by 5 operand, which is B. So we'll say C equals A downshifted by B. I don't know why that capitalized. I don't know why that kept. Get out of here. Okay. 4, 5 is B XOR C. So B equals B XOR C. 1, 3 is going to be B XOR B equals B XOR and then the value 3. 5, 5 is going to be output A, 5 B, output B, now lowercase b. And then 0, 3 is going to be A shifted down by the operand 3. So A equals A downshifted by 3, and then we loop. Okay, so what are we doing here? There's a couple things to look at. Notice right away. B and C don't matter. Like the only thing that carries over from loop to loop is A, because the first thing we do is we take A and set it to B, and then we take C is based on the B and the A. So the B and the C from each loop don't matter. The only thing that matters is the A. Next thing we can look at is that it only, like A is used and then it is downshifted 3. So the bottom 3 bits get pushed off in the bottom. So if we look at what is going to generate this 0 on the end, it's going to be the highest 3 bits of A. And then the next 3 bits of A are going to generate this 3, the next they're going to generate this 3, etc. So we can kind of work this recursively backwards to find the answer. I don't want to reverse engineer this to figure out exactly what's happening. So what I think we're going to do is we're going to kind of run we're going to run our program because we can only do, okay, I think the number's going to be large because it's got to be big enough to produce, it's got to be, at least this many things shifted by that times 3. So I forget we counted earlier, but it's big enough that we're not going to brute force this for sure. So what we're going to do is we're going to turn our computer into a program or our computer into a function, and then we're going to call the computer on smaller pieces of A to try to check B. So let's go with it here. First thing we do, let's refactor so that we can get a function here for computer. So I'm going to take all of U and shift U in and do def computer A, which is an int. I better take B and C, although they're effectively, I'm going to always just assume they're 0. So 0, because we've proven we don't really care what they are. The initial values don't matter, but I have to define them or they won't the whole thing will fail. So let's do list int like that. And now in our thing, we're going to do our thing, and we will get our output, and we just need to return output. Is that the right place? Yep. So now we should be able to say this is computer of A, B, C, just for the sake of completeness here. And if we do Python day 17 example, that does not look right. Wonder if we need, just for the sake of keeping, I'm worried about our A's and B's all over the place. I'm actually gonna take this and put it inside here. Like that, so it's just for the sake of, does that solve me? Yeah, I think that was what I think. So basically, I've got A's out here and A's and B's and C's in here, and I've got this combo function sitting outside of a scope. And so when I call, and I probably should be making a class at this point, but it doesn't know which A's and B's to use, and so I think putting this function inside the scope of the other function tells it use the A's and B's and C's from there. All right. So now we need to. Is that right? I guess I should check to see. Where's example of 1? 4, 6, 3, 5, 6, 4, 6, 3. Yeah. Okay. So it looks good. Okay. So now my part 1, I've done all I've done is part 1. Okay. So for part 2, what are we going to do? We're going to say candidate equals 0. We'll start with just like putting in nothing. We have no existing A. And we're going to say for L in range len program. So we're going to loop over our program. Hold on, maybe we should do this manually a little bit first so we can make sure we figure it out. If we do Python day 17, let's do our input.text with a -I. So if we say computer of 0, I get 1. If I say computer, so now if we look at what we're doing in our thing, I don't have a good way to, didn't mean to close that. Notes, over to the side, split down, move over. Okay, so we think putting in a 0, or putting in a 1 is going to give us this 0. Now we're going to shift that up 3 bits, which is basically multiplying by 8. So now if we put in computer of 8, there's actually 2 possible options that generate this 3. There are actually, we're testing to generate 3, 0. Oh no, sorry, that gives us 3, 0. If we put in computer of 8, we get 3, 0. Yes. Okay, so now the question is, if we multiply that up as well, so is that putting in a 64? That does not give us 3, 0. So 64 does not give us the right output. Does 65 give us the right output? No. 66? No. 67? Yes. 67 did. We should check. We can check. 68? No. 69? No. 70? 70 did as well. So basically there's 8 possibilities here that can go. It's from 64 up to 71. I guess we check 71. We can see of all of those, 2 of them actually, 67 and 70, started us down the path of something right. Now I want to loop through my program looking for possible answers that give us that. So we need to do what we're going to do. Okay, we're going to say for L in range len program. So for every space of the program, I'm going to say for we need a candidate. So candidate equals, we're going to start with just simple 0 because that's all we need. We'll say next candidate equals that. And now we can say for val and candidates. So for each val, each possibility of this point, we're going to say for I in range 8, we'll get the possible next values. Target equals val upshifted by 3 plus I. So that'll give us we'll try each of these 8 values, and we can say if computer target equals program, and then I need to go, let's see. So when program is, when L is 0, on the first one, we want to match 1. So we want that to be negative, we want this to be -1 to the end. When L becomes 2, we want this to become negative. When L becomes 1, we want this to be -2 to the end. When L becomes 2, -3 to the end. So we are going to do -L minus 1. Like that. I'll say if those match, then next candidates dot append target. So, and then once we get through, we'll come down here and say candidates equals next candidates. So we'll get all the possible values. So for each candidate, we start with nothing. We get the possible next values. We find all the good ones that could generate that much of the end of the list, and we put them here. And then we loop and we go for the next longer thing. And then we try all of those candidates for each possibility there. And if we get good ones, we go. And I mean, I think we can try it. Oh, I should, let's see. So let's see what does candidate say? I guess we need minimum of candidates. We get nothing, so that's not. Oh, on the example, let's try. I don't know. I don't know if this will work on my example. Yeah, okay. So we're missing something here. Let's see. Next candidates, valid candidate. Let's do this. We'll print candidate here. And we're getting empty targets. We're always failing. Is this a 1? Did I do a 1 minus? Did that be my problem? That's kind of cool, actually. We can see the candidate list grow. So we can see that there's 2 candidates, there goes to 4, it goes to 4, stays at 4, then it starts going up, but some of them start truncating out too, and you can see eventually we come down to just 1. That's kind of cool. So did this work on example as well? I don't see why it shouldn't. It doesn't though. Maybe my example might not have, well, let's not stress about that. We can, I guess I might peek at that later, but so we can get rid of current candidates. Let's see if this is right. Is it min? I just do min candidates. And we got an answer. Let's see if it's right. Boom. Okay. So basically what we did is we just sort of loop through and work backwards, figuring out everything that can possibly be a candidate. And till we get to just, there's only one left at the end, but we get the minimum one and we solve it. Neat challenge. I like this one. Yeah. Thanks for hanging out with me today. I'll be back tomorrow.